Welcome to today's lecture, which is module 301 completion, and it's about module 301.4. I understand how the redeemer is used in Plutus validators. And the role of the redeemer is to manage the flow of your script validation. In our example, we call it action, which means it's basically based on it that we control the flow of the user's interface with the validation process. And just like the datum, the redeemer is an arbitrary data type. That data can be used as a validation reference, in our case, the flow, and it's also used to manage your own validation and checks. The value of the redeemer is not explicitly checked by the validator. However, it does need to expect a validator through the use of the redeemer when you're interacting with the smart contract. So you need to have a redeemer when you want to retrieve funds from the smart contract. When you send, you don't need it, but when you retrieve funds, you do need a redeemer. The syntax is within the validation process is still the second element of the validation function, the redeemer. I'll cover a little bit about the parameter this time to see how the parameter are also used. However, in the case of the redeemer, just like the datum, is a necessary part of the redemption of funds on the smart contract. And as just like the datum, there are different cases that explain how the validation may be true or not true. What can you use as a redeemer? It's any form of data. You can use an integer, you can use a string, you can use some other data type, data definition, or some indexed data type, as we'll be using in our example. How do we update the redeemer from last example we used? You'll notice that I've changed the redeemer type. First of all, I used another type, which is this form different. It's a data starter action. I added the R, capital R before action, and it has 4 different parameters: true first, false first, true second, false second. Intuitive, that's what they will be doing. And then you add this text to basically say that it's an index data type. The name of the func of the data type, which is in our case starter action, and it is again true first will be indexed as 0, true for false first indexed as 1, true second indexed as 2, and false second indexed as 3. And then we make lift the starter action. And the utility is to manage the flow of the validation. As you can see, this validation function is kept as it was. I just changed the name here by adding the new data type name. Instead of starter action, I'm calling it starter action, and using that new name, I'm able to basically use the same name definition in the function. However, now I'm using different cases of the action type, action parameter, which is in the case it's true first, then the validation is true. In case it's false first, it's false. In case it is true second, it is true. False second, it is false. And any other file you send will also be false. So you can change the order and see how your own validation work, and you'll see that indeed that's what is happening. I have not sent false error messages, but we'll be handling it in a bonus lesson I'm preparing again today for you to see how the error will be explained to you. However, we know that the true first will be true, false first will be false, true second will be true, and false second will be false. And the redeemer files, there will be 4 redeemer files, and they're all almost similar. They're only differentiated by the constructor index. Remember the index which I mentioned in the creation of the data type? So true false will have index 0, false first will have index 1, true second index 2, and false second index 3. That's the only difference between those four files, is the value of this digit here, which is the constructor index. And in the next lesson, we'll be following on how you can combine the datum and the redeemer to make your validation more complex. Some cases we'll see is to getting from the datum the rightful owner who can sign, and also you can also see through the datum the stage at which your smart contract has gone. We had seen already in the previous lecture when I was showing the datum, you saw a stage where I had the datum which has an indicator open that can be used basically to check the status of your smart contract flow. So now we can go ahead and try this as the example. As you know, I have created the smart contract address using the new Plutus script. You'll get a new Plutus script once you run the Cabal repo by modifying the other validator, and that will give you a new address, because as you can see from our validation, we have basically first changed the data type, but also we exported the new redeemer before we use it in our validation here. So that's why we received a new address, and most of the time when you change the script logic, you do get a new address. But that's why here we have an address which is, as you can see, it's empty. We're going to quickly send funds. The same flow, we need to know to get some UTXO from address 1. Okay, so I'm going to send again, good habits, 48 ADA. Let's see what we have. This one should be enough. Index 1. I use the same template. Index 1, I'm going to send 48 ADA in this case. Okay, and we know the Plutus in use, that's the one. Script, that's the one. Perfect. So let's use this. I've already created this address, that's why I'm able to basically get the S address. But just to let you know, let me just send this, and then we're going to basically send 48 ADA with a datum value of 48 as well. Okay, so we have here, we have still the same syntax. Address 1 with the change, takes in to pay the fees, sending to the smart contract 48, the value of 48, and then the file will be called 10.8, 10.48, 10.48, September 10.48. Okay, so let's send this. And then let's sign that. It's relatively quick, given that we have done this already. So it's always handy to keep a template to use. And in the previous lecture, I wrote the process, and now we can query again the UTXO of the smart contract. Done on CLI, query UTXO, put address, the smart contract address, which network, the testnet, which is testnet product preprod. So we have the 48 ADA, and we know it's an inline datum. We can read the value, which is value 48. So now we're going to retrieve this one using address 2. Let me see what funds I have on address 2. Same. Okay, so I'm going to use this one to pay index 0. The collateral is always the same. I'm not changing it. It's not being consumed. That's why I have it here. This is my collateral, which I always use here. And then we're going to get the funds, which is this ones we're going to consume with index 0. Okay, so I use the same template. Contract index, collateral UTXO, fees UTXO. Always the same. Now let's see what we do with the. So let's see, now it's inline. So inline we don't need. This one is the inline script, fees, collateral, contract with the script in use, which is the one I just defined. Inline is present, text in redeemer file, redeemer ts json. Let me show you how the redeemer files look like. This is the redeemer false second with the index. Okay, so let's use the redeemer false second first. Okay, redeemer false second, it's false, so it won't work. Still change to, I have mine here. Okay, perfect. So let's go copy. So I'm using the false one, it should not work. Okay, so there is an error. However, I did not give an error message from the script. As you can see from here, I did not define an error message for you to see, but in the bonus lecture I'll show you how to get an error. But this type of error is basically meaning that there was an error, and the log is that this type of error. Now let's change the file and put in the true, whichever you want, as long as the true here, it could be the true second or it can be the true first. They will all succeed. Okay, what true first? True first is the one with the index 0. Where is it? True first, this one here, it should work. Okay, so true first. Perfect. So you can see the value has gone, and now I can sign the file. Then move that file. What did I call it? 1048. Copy 1048, sign 1048. Sign this. And then let me submit it. The transaction has been successfully submitted. Now we can check the value at the Cardano contact address. Still not consumed, we're waiting for it. Okay, still waiting. I hope that I took the right ETXO, which is, let me see, yes, which is 7.0 index 0. Yeah, so that's the right one. It should be consumed. Still waiting. Let's see the node, whether I have a connection. If my node is complete, is synced. It was at 99.90, but I had already submitted the transaction. There is some object in the memory pool, so let's wait for it to clear. When it clears, I should be able to see the updated value on the smart contract address. Maybe I lost my internet connection. There is a process which is keeping this stuck. Okay, so now there's been a new tip. Let's go and see what happened to this value. Good, so now it has been updated and there is nothing at the smart contract address. Good, so thank you. This is it for today. And as I said, I'll be showing you a bonus lesson through which I pulled the identity of the signee from the datum value, which is going to be another data type, such as we have modified this redeemer type. And through that datum, we'll be able to identify who has the right to sign. In one case, I'll make payment one being able to sign and receive funds, and the other case in the flow, I'll be making payment to the only signee being able to retrieve funds at the smart contract address. But those are the two usages of the datum and the redeemer. And should you have any question, please reach out and don't hesitate to ask for support and help. Thank you. Bye.